So my next career was software manager in the Air Force Space Program. And the Air Force needed a heavyweight upper stage that could take a heavy reconnaissance or communications satellite and get it way up into geosynchronous orbit. And so the Air Force took over this program and worked it with NASA because basically they were going to be launching it off of, well, let me talk about the orbit first. Basically, this is a Hohmann transfer orbit. There's a lot of different transfer orbits. This is one of the most fuel efficient ones. It's the one the IUS used. So the IUS would fly in the back of the space shuttle or on top of the Titan. In the back of the space shuttle gets into an orbit, kicks the IUS and the payload out, and the IUS is basically a robot. It knows what it needs to do next. And it fires its first stage, gets it out to geosynchronous orbit, fires a second stage, putting the satellite way out there at 22,000 miles. These are the missions. I was involved in the IUS back in 82 to 85, and so the missions I was involved in was the very first flight off the Titan 3-4D. Then the next flight was a Challenger, and that actually had a failure issue with the IUS. The second stage of the IUS had a O-ring seal. You may have heard that phrase before. That failed, and the nozzle cocked over, and so towards the end of that burn, the second stage of the IUS and the TDRS were spinning like this, and it would not respond to any of the commands we were sending up to try to get it to pay attention and do something different. It was designed to be autonomous. But we had realized before the flight we wanted the capability to be able to tell the robot what to do if something seemed to be going wrong. Things were going wrong. The smart engineers at Boeing figured out that it would not go into this next stage of flight and allow it to listen to our commands and do the next thing we wanted it to do, which was to let go of the TDRS. It wouldn't do that because it thought it was still accelerating. Because it was spinning, the accelerometers in the IUS thought it was accelerating forward and would not go to the next stage of flight and release the TDRS. If we could just get it to release the TDRS, then the TDRS could stabilize itself with its own rockets and get it into its own correct position. The thing that saved the day was my young lieutenant, Cindy Halliday, who had the screechiest voice on the net. And she yelled at everybody and got them to pay attention and gave them the command to send. They sent the command and it saved the mission. So screechy voice, asset. You'll see that the missions that it flew included interplanetary to the Sun, to Venus, to Jupiter. There was a version designed but never flown that was a 3-stage version that could take it even farther out to the solar system. And I just got a couple of gee whiz photos here to show you. The entire stack of the space shuttle is about the size of the Ogden Municipal Building, if you want to try to picture that. If you ever get a chance to visit Kennedy Space Center, if you ever get a chance to walk up to the old gantry that's there, while it's still there, the experience I had when the shuttle was there waiting to take off, and I was going up to the checkout station to look at the IUS that was on board, my experience was I kept walking and walking and walking. It got bigger and bigger and bigger, and I kept thinking it can't be much further because it's so big now, but it just kept getting bigger. But that's the scale of that. That's the scale of the Titans that flew it, the shuttle flew it, and a couple of different versions of Titan flew it. IUS itself is 17 feet high. And these are the interplanetary missions that it flew, Magellan, Galileo. And then TDRS, some of you probably don't even remember this, that back in the day the space shuttle was first launched, it was like the old Apollo or the Gemini. It would go into areas around the Earth where there was no communications. There would be radio communications would be blacked out because there wasn't any antenna anywhere it could communicate with. TDRS is a series of satellites that provided that communications link and other things for the space program. So now anywhere you are in orbit, anywhere, you're able to communicate. This is another shot showing you scale. Here is an astronaut sitting on the, this is the device that held the IUS in the back. Basically, the astronauts would be out in front and they'd fire, they'd push a button, a squib would fire that would sort of unzip it, and a spring would gently push the IUS out. One more thing and I'll answer your question. The astronauts were not really in love with the IUS. They certainly liked it a lot better than putting a liquid-fueled Centaur in the back, since it was a solid-fueled upper stage. But they didn't like the idea that it was an autonomous robot, and as soon as they kicked it out, it was going to do whatever it thought best. And so on their power control panel in the back of their flight deck, they had a big red button called the master reset. And if they started to get nervous about anything, they could hit that button, and it would give them one more orbit before the IUS would decide to do anything. And of course, what they didn't want was for the IUS to position itself to just the right angle for its first stage firing, and for the shuttle astronauts to look at that and say, hey, that engine's pointed at us. That's not good. That never happened, fortunately. You had a question.
Did I miss you saying what the IUS stands for?
Inertial, that's a little story there too. It was originally called the interim upper stage, because it was the intent of NASA and the Air Force to put a liquid-fueled Centaur in the back of the shuttle. After the first shuttle disaster and everything blew up, they decided they were really never going to be able to get a liquid-fueled upper stage past any of the safety officers or safety engineers. So they stuck with the IUS, changed its name from interim upper stage to inertial upper stage. The acronym folks are always able to find a way. And this, now on to intercontinental ballistic missiles, the third major area of my career.